The cosmic distance ladder, how we measure the universe. The study of the universe has long been a subject of fascination for humanity. From ancient times, people have looked up at the stars and wondered about their nature, their composition, and their distance from Earth. Over the centuries, astronomers have developed a variety of tools and techniques to measure these distances. One such technique is known as the cosmic distance ladder. So why is it called a ladder? The term refers to the fact that the ladder is made up of a series of steps, each of which builds on the previous one. By climbing up the steps, we can measure the distances of objects that are increasingly far away, until we reach the very edge of the observable universe. The first step on the cosmic distance ladder is the measurement of the distances to nearby objects within our own galaxy, the Milky Way. This is done using a technique known as parallax. Parallax is the apparent shift in the position of an object when viewed from two different positions. To understand this, hold your finger up in front of your face and close one eye. Then open that eye and close the other one. You will notice that your finger appears to jump back and forth slightly. This is because your two eyes are seeing your finger from slightly different positions. Astronomers can use this same principle to measure the distances to nearby stars. They observe a star's position in the sky in relation to a more distant background of stars. Then, they measure the star's position again 6 months later, when the Earth is on the opposite side of the Sun. By comparing the two positions, they can calculate the angle of the apparent shift in the star's position, which is known as its parallax angle. The next step on the ladder involves measuring the distances to other nearby galaxies outside of the Milky Way. This is done using a technique known as Cepheid variable stars. Cepheid variables are a type of pulsating star that oscillates in brightness over a regular period of time. The brighter the star, the longer its period. By observing the period of a Cepheid variable, astronomers can determine its true brightness, which is related to its distance. The technique works like this. First, astronomers identify a Cepheid variable star in a nearby galaxy, whose period can be measured accurately. They then observe the star's brightness and period, and use these data to calculate its true brightness. They can then compare the star's true brightness with its observed brightness, and use this comparison to calculate the distance to the galaxy. The third step on the ladder involves measuring the distances to even more distant galaxies, beyond the reach of Cepheid variable stars. This is done using a variety of different methods, including the brightness of supernovae, the movement of galaxies, and the properties of galaxy clusters. Supernovae are extremely bright explosions that occur at the end of a star's life. By studying the brightness of a supernova, astronomers can determine its distance. Specifically, they look at the brightness of the supernova at its peak and compare it to the expected brightness for that type of explosion. They can then use this comparison to calculate the distance to the galaxy where the supernova occurred. Another method for measuring the distances to galaxies involves studying their movements through space.